Evaluate the integral cos 2x sin 7x dx. Have you seen that? Now we say when it is a product of two functions, you use integration by parts. The integration by parts is only used when the functions are different. I talked about that, isn't it? Maybe when this is trigonometric and this hyperbolic, or this is polynomial and this is trigonometric, when the functions are different is when you use integration by parts. But integration by parts, you can as well use it when it is the same function which has been manipulated. Is when you use integration by parts. When it is a single function, you manipulate it to be two. Like I'm saying, you want to integrate sec cubed x dx. You can manipulate sec cubed x to be sec squared x sec x dx. Then you say this function is different with this. Meaning you can only use integration by parts when it is the same function which has been manipulated. Are you getting the concept I'm talking about? When it is the same function which has been manipulated. It was just one like this, but you manipulated them to be two so that you use integration by parts. But if there are two, they have to be different. You are getting the difference? Good. Now this one, how do we ensure that, how do we integrate a product of two trigonometric functions? You know that is in product, identities and factor formulas in trigonometry, isn't it? So when were you getting cos and sine? Was it the cosine sum and difference angle formula, or it was the sine sum and angle difference sum, sine sum and difference angle formula? Which one was giving you cos sine? See, it was sine. It was sine, isn't it? Meaning, if you have sine A plus B, you are getting sine A cos B plus sine B cos A, isn't it? Then if you had sine A minus B, you are getting sine A cos B minus sine B cos A. Now you check, you have to get rid of one of them. So because at the end you have cosine, this is cosine, this is cosine. So you see, do I add so that I eliminate the second one, or do I subtract so that I eliminate the first one, isn't it? So before you choose whether you are adding or subtracting, you check what you want. Are you seeing that? Here we have A minus B, meaning A must be bigger than B for you to not to get a negative number inside. Are you seeing the concept? This is A minus B, meaning A, between 2x and 7x, which one do you let to be A? You let the one which is big. Are you seeing that? So it means this 7x is the one you put to be A, and this 2x you put to be. So it means we are looking for sine A. So it means you are going to take the one which has sine A. Are you seeing the criteria? Because A minus B, A must be big, isn't it? But between cos and B, between 2x and 7x, which one is big? See, 7x is big. Yes. So 7x is what you put to ABA. So we are looking for sine A. So for us to get sine A, it means we add the two equations, isn't it? Because if we subtract the two equations, we are not going to get sine A, we are going to get cos A, but we don't need cos A, isn't it? Yes. We need sine. Is that okay? So you add the two equations. So if you add this side, you have sine A plus B plus sine A minus B to be equal to this plus this. You have 2 sine A cos B. Are we together? Now what you do is this. Look at this. This is what you do. You don't need to come and divide both sides by 2 so that you remain with sine A cos B, because cos B sine A is the same as sine A cos B. Senior. You don't need to divide both sides of the equation by 2. What you simply do, you multiply a side by 2 and you divide by half. It is like 2 over 2. Are you seeing? Senior. So that you now have 2 cos B sine A or 2 sine A cos B. This one is the same as this, isn't it? So can you now substitute back? This is sine A plus B. A is 7x, B is 2x. So 7x plus 2x, this is 9x plus sine A minus B. 7x minus 2x is 5x. Is equals to 2 sine A. But A is 7x, B is 2x cos 2x. So it means where there is 2 sine 7x cos 2x or 2 cos 2x sine is the same thing, isn't it? Where you have this, you substitute with this because you cannot integrate it when it is a product, but you can integrate them when you separate them, isn't it? Are we together there? It can be integrated when they are separated. So you've now found this is the case. So can you now go back to your problem? This is the final thing we found. So when you're now integrating, you now have here is a half integral. The whole of 2 cos b sine a. 2 cos b sine a, you found the whole of it is this, isn't it? So we have sine 9x plus sine 5x dx. So can you now integrate that? So you have a half is common for both of them, isn't it? You have a half into, let me just integrate direct, a half into, if you integrate sine 9x, okay, differentiating sine you get positive cos, meaning if you integrate sine you get negative. So we are going to get negative cos 9x, then you divide by the derivative of the inner function, isn't it? The inner function, the derivative of the inner function must be a constant. So if you differentiate 9x, you get 9. Meaning after integrating, you divide by that, isn't it? Are we together? Then, plus, if you integrate sine, would you get negative? 5x. Then you divide by the derivative of the inner function, isn't it? If you differentiate 5x, you get? That inner function must be a constant. That's the reason why we are getting rid of any power in integration, isn't it? Unless the power is resulting from a standard integral, like sec squared x. If you want to integrate sec squared x, you just get an x standard, isn't it? Good. Then plus c. Then you take your power half inside. Power half is common for everything, isn't it? You don't forget. Power half is not only for this, it is for both of them, isn't it? So a half times negative 1 over 9 is negative 1 over 18 cos 9x, isn't it? Then a half times negative 1 over 5 is negative 1 over 10 cos 5x plus c. And you've actually integrated your final, your initial problem, which was cos 2x sine 7x. Meaning if you integrate cos 2x sine 7x dx, that is what you're supposed to get in case of an indefinite integral, isn't it? If you have the limits, you remove c and you put the limits of integration in case of a definite integral. Are we together there?